Now, Laurent, what I suggest is that our English speakers are going to listen to Katie as well. Katie, who is going to talk during the last 3 minutes of the countdown, and we are going to continue with our French friends.
Yes, so we are 2 minutes now and 50 seconds to launch, and we can confirm, yes, that the was given due to the launch zone and not the launcher itself. And if you take a look there at the top of the launch vehicle, you can see those big yellow structures 3/4 of the way up. Those are called the cryogenic arms, and they are clamping onto the top of the launch vehicle, and they are feeding cryogenic propellant into the vehicle. That's propellant which is kept at unbelievably low temperatures. It's liquid hydrogen and liquid oxygen. The hydrogen is minus 253 Celsius and the oxygen minus 150 degrees Celsius. And of course it's so cold that it tends to evaporate. And that's why we top up those tanks right up until the last few seconds. In fact, you'll see those arms withdrawing 6 seconds before the launch. And here you can see the teams, the VIP guests coming out onto the Jupiter control room terraces, getting ready to watch the launch now from outside with their own eyes. We are 1 minute and 27 seconds to launch. Looking here at the range operations manager, waiting for him to announce the final minute.
À toutes les vidéos, attention pour moi, 1 minute. Stop, à 0 moins 1 minute.
And we are 1 minute to launch. We're live at the Guyana Space Center. The launch of Horizon 3E for Intelsat and Sky Perfect JSAT Corporation, built by Boeing, and Azerspace-2, Intelsat 38 for Azercosmos and Intelsat, built by Space Systems L'Oral. Our very best wishes now to all the teams. Let's sit back and watch the launch.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage EAP et décollage VA243 ceinture Ariane 5. Sont nominaux. La propulsion est nominale. Trajectoire toujours nominale. Sont nominaux, la propulsion est nominale. La propulsion est nominale.
Ariane 5, the 100th launch today. There she is, blazing a trail across the night skies here at the Guyana Space Center. I have to tell you that it's really remarkable seeing that with your own eyes and hearing it. You can actually feel the vibration. Coming up on separation of the boosters, hopefully we will see that with our own eyes. We've been very lucky to have such beautiful clear skies tonight.
Séparation des deux EAP.
And we have confirmation there of the separation of the two boosters. So we are shedding weight. They burnt their propellant. We don't need them anymore. And you can see them there. Those two dots going to the right and left. And the dot in the middle is actually the Vulcan engine. It's the engine of the main stage. So you can see the launcher is flying away from us. Over now to the CGI images to look at that.
La propulsion de
Look at the front of the vehicle, you can see that's what we call the fairing. The pointy bit at the front, our satellites are in there. It's protecting them from the rigors of the launch. But if you look at our altitude on the bottom left-hand side of the screen, you can see that we are now 100 kilometers above the Earth, and there's no longer any friction because the air is too thin for that to cause us any problems. And you can see this is the scheduled moment for separation of the fairing, and we've had that confirmed now by the range operations manager. And we can see how it bends as it falls there. It's all part of the flat plan. It's called the breathing mode. So I am joined now here on the terrace by Laurent Jourdain, who was in the commentary box with Thierry. Hey Laurent, thank you very much indeed for coming here.
It's a pleasure to be with you tonight.
It's quite something, isn't it, watching a launch like this?
Yes.
You've seen a lot of these, but
yes.
Does it ever wear off?
I always. First the light and then the noise which vibrates internally and externally. It's amazing, always.
And then, of course, we had to wait for about 40 seconds or so before we actually heard it. So, Laurent, you must have seen a lot of launches, though.
Yes, I arrived there for flight 27. So that's almost 216 launch up to now. And 217 now.
217 launches. And so, I mean, what does it mean to you to have seen all these launches and to be part of such an important process?
Yes, usually in campaign I am the leader of the technical authority team for the launch vehicle. So I usually am in the CDL3 that you see just before. And I do not see the launch vehicle lift off at real time like it is now. So it is inside the blockhouse. But
that's quite a privilege for you to have seen it. And of course, because you've worked here for so many years, I think you were saying, what was it, 25 years with Arianespace
yes.
and 30 years in the business. It's really all about the people, isn't it, who make the space business.
Yes, it is really a human odyssey for this space activity, and I really I'm proud of this, let's say, competence and skillness which is always given to succeed these launches and prepare them for weeks and weeks. And today I really want to specially, let's say, give a warm thanks to Reinhard Hildebrand, which is who arrived in French Guyana in 1984 and which will retire just after this launch, and all these years of patience and activeness on the launch vehicle activity.
And we actually saw Reinhard Hildebrand working. He's working tonight in the Launch Control Center, which is where you've spent many of your years.
Yes, that's right.
Working. And I was talking to him earlier, and he was telling me about how when he started back in 1984, they just had a little one fax machine. Listen, Laurent, thank you very, very much indeed for joining us. I'm going to send you back now to Thierry, and we are going to have a little look at the 100th anniversary of Ariane 5. Merci Laurent, désolé.
Le pilotage est calme, la propulsion est nominale. 5, 4, 3, 2, sur le président.
Off the screen. Our flight path takes us out across the Atlantic Ocean, along the equator, across Africa, and we'll start separating the satellite off the east coast of Africa, this Charlotte Biscuit. And the ground stations along the flight path are tracking Ariane as she flies over, and we call it telemetry. And right now the main stage is getting ready to switch its engine off. It's called the Vulcan engine, that's it, on the left-hand side there of the big tube in the middle, that's the main stage. It's been propelling us into the sky for 9 minutes now, nearly 9 minutes. It's extremely powerful. It burns 320 kilograms of propellant per second. And here is the scheduled moment now for the separation of that. So the main stage engine has switched off and the upper stage engine switches on. We started with 776 tons and now we've only got 30 tons left. So we've only got 3% of our original mass. And we're really beginning the next phase now in the journey. The upper stage has taken the wheel. Its job to transport the satellites. He's telling us that the propulsion is normal. Its job is to transport the satellites to their correct orbit so that we can release them. And we call this geotransfer orbit. From there, they'll have to travel on their own to their final position in space, which is called geostationary orbit. And that's 36,000 kilometers above the Earth. And the first satellite to be separated will be Horizons 3E. The owners are a joint venture between Intelsat and Sky Perfect JSAT. Intelsat is one of the world's leading satellite operators, and Sky Perfect JSAT Corporation is Asia's largest satellite operator. And Intelsat, Sky Perfect JSAT, and Arianespace are old friends. They've launched many times before, over 3 decades, and Horizons 3E will be the 60th satellite to be launched by Arianespace for Intelsat, and the 20th Sky Perfect JSAT-1 to ride from the CSG.
As you saw, the fairing has been jettisoned, and for the first time, the Intelsat satellite Horizons 3E is now visible on the top of the 100th Ariane 5. Horizons 3E is the 4th Boeing 702 MP satellite to be launched on Ariane after Intelsat 29E, Intelsat 33E, and Intelsat 37E that was launched just 1 year ago. Contrary to its predecessors, Horizons 3E carries an electrical propulsion system using xenon ion thrusters, also known as XIPs. It has a separated mass of 6,441 kilograms, including around 2,500 kilograms of propellant. Since the beginning of the success story between Intelsat and Ariane, 40 years ago, Horizons 3E will be the 60th satellite of the Intelsat fleet to be orbited from here. Horizons 3E is also the 25th satellite to be launched for Sky-Perfect JSAT. So thank you to the Intelsat, Sky-Perfect JSAT, and Boeing teams for their confidence, and we are looking forward to working again soon with you. All the best to Horizons 3E.
You can see on the right-hand side of the screen, we can actually see the images of the satellites in space. The blue light you can see there is effectively the main stage engine. He's telling us that everything's going according to plan. And as we turn around here, on the right, you can see that we have the horizons. He's telling us there's a planned loss of telemetry there for a few seconds, which has all been planned and organized, and then we pick that up again shortly. Gone out of visibility and coming back in. And you can see there the Horizons 3E satellite at the front. Then in the middle is a black structure. We call it the Silda. And that's allowing the attachment of one satellite at the front and protecting another satellite in the middle. So Horizons 3E at the front and Azerspace. And we've picked up the signal at our next tracking station. Over to a film.
Thank you for joining us for the launch of Horizons 3E, the sixth of our Intelsat Epic high-throughput satellites. This launch marks our fourth satellite project with Sky-Perfect JSAT. It epitomizes collaboration within the space industry and the benefits that our partnership yields for the customers we collectively serve. Today represents a great milestone for Intelsat as Horizons 3E completes the first phase of our next-generation satellite network. Horizons 3E will increase Intelsat Epic's capabilities in Asia, expand coverage in the Pacific Ocean region, and become the first truly global C and Ku-band high-throughput network in the market today. Horizons 3E advances our Intelsat Epic technology. The satellite's enhanced digital payload features the highest throughput of the entire Intelsat Epic fleet. It has full-beam interconnectivity in C and Ku-band and significant upgrades to power, efficiency, and coverage flexibility. The satellite's unique features will provide greater flexibility to our customers located at 169 degrees east. Aeronautical, maritime, mobility, and government customers will be able to match the satellite's capabilities with traffic demands. Fixed and wireless network operators will be able to cost-effectively expand their 3G and 4G networks and bring affordable broadband connectivity to communities and businesses in both developed and remote areas of Asia-Pacific. As we've seen with other Intelsat Epic satellites, corporate and enterprise networks will leverage the higher power and greater efficiencies to expand their networks to developing areas of the region and take full advantage of the resiliency and redundancy of our network. Horizons 3E provides additional resiliency to our Intelsat One Flex managed service platform, completing our global coverage and benefiting global maritime operators and corporate enterprise networks. On behalf of Intelsat's employees around the world, I'd like to thank our manufacturer Boeing and our launcher Arianespace for their commitment to delivering a successful program for Intelsat. We are pleased to be part of the 100th launch of the Ariane 5 rocket. The Ariane 5 has launched 17 Intelsat satellites over the past 18 years. We extend our congratulations to Arianespace on this milestone. I'd also like to recognize the Intelsat team for their work on Horizons 3E. Your colleagues are proud of your technical excellence and leadership. We appreciate and applaud your efforts to make Horizons 3E a success. Finally, let me express my sincere appreciation to our customers for their continued trust and for taking this epic journey with us. Go Horizons 3E!
Epic indeed, and we've picked up the signal at the tracking station in Ascension Island, which is following us now. It's a volcanic island in the middle Atlantic. halfway between South America and Africa. Top right hand of the screen, you can see what we call a roller coaster. Before we were using all our energy to get away from the Earth, but now we are using it to go faster so that we can start going higher later in the flight. So we decreased our altitude a little bit to pick up speed. We need to climb to 1,108 kilometers to separate our first satellite. Let's turn our attention to Azerspace-2 Intelsat 38. Azercosmos and Intelsat are sharing capacity on the same satellite, which is why it has the two names. And if we start by looking at the Azerspace-2, the satellite for Azercosmos Open Joint Stock Company, it's a new satellite operator which is evolving fast, and it's the only operator in the Caucasus region. Azerspace-2 is the second satellite for Azercosmos. Arianespace also launched the first one. That was in February 2013. Let's get a closer look at Azerspace-2 Intelsat 38.
I'm proud and excited to be part of Azerspace-2 project. This project is of great importance not only for Azercosmos, but also for whole Azerbaijan. Our team has spent a lot of energy and dedication to make this launch possible, and finally, this day has arrived. The Azerspace-2 satellite consists of 35 active K-band transponders. The satellite is designed to provide services such as digital broadcasting, internet access, data transmission, and the creation of VSAT multi-service networks, and other services for commercial and government customers. The satellite will be located at 45 degrees longitude and provide service in Europe, Central and South Asia, Middle East, and tropical Africa. This launch is not our first cooperation with Arianespace. Our first telecommunications satellite, Azerspace-1, was also successfully launched by Ariane 5. So I would like to thank them for their reliable partnership and customer focus. I'd also like to express my appreciation to the satellite manufacturer SSL, as well as Intelsat for their invaluable support during this program. It was a great pleasure for me to be part of such an experienced team. Good luck to all of us.
And you can see that we're tracking now the satellite, the launcher, using the ground station in Libreville, which is in Gabon, the west coast of Africa. So we've crossed the Atlantic Ocean, and you can see with our trajectory on the right-hand side, really starting to climb into space now. So let's look at the Intelsat 38 part of Azerspace-2. Intelsat 38 spacecraft. It'll help Intelsat to expand its TV and broadband satellite services in Central Eastern Europe, Asia and Africa. It's a region where demand is growing very fast. Arianespace is proud that Azercosmos and Intelsat chose them to launch their satellite because it shows their confidence in Europe's launch services. Let's get a little bit more information now on Intelsat 38's mission.
Thank you for joining us to watch the launch of the Intelsat 38 and Azerspace-2 satellite. It is great to be sharing this day with our partner Azercosmos. Together, we're expanding satellite services to support the growing distribution and broadband connectivity demands of Central and Eastern Europe, Asia, and Africa. Intelsat 38 will provide Ku-band capabilities and deliver continuity of service for the Intelsat 12 satellite located at 45 degrees east. The satellite will host leading direct-to-home television platforms for the fast-growing Central and Eastern Europe and Asia-Pacific regions. It will support the growth objectives of our customers operating in these regions. Intelsat 38 will also provide critical broadband connectivity for corporate network and government services in Africa. None of this would be possible without the dedicated partners who share our commitment to build a more connected world. On behalf of Intelsat's employees around the world, I'd like to express our appreciation to Azercosmos, the manufacturer SSL, and our launcher Arianespace, and to the Intelsat team. Your colleagues around the world, thank you for your commitment to excellence and to this mission. It's greatly appreciated. Finally, let me express my sincere appreciation to our customers for their continued trust in Intelsat. Wishing us all a successful mission. Go Intelsat 38.
You can see the tracking stations there along the flight path. Galileo was the one back in the CSG, Natal in Brazil, Ascension Island, and now we're using Libreville on the west coast of Africa. You can see the little dot there in the screen is our launcher flying over the planet. Just talk you through the screen. At the bottom of the screen there we had the altitude, 344 kilometers and climbing. Look at the curve on the right-hand side of the screen, really heading up into the skies now and into space. And our distance in the middle is actually the distance from the pad if you were to draw a straight line from the launch pad to the position where the launcher is. And on the bottom right-hand side, on the right-hand side is our speed, and it's kilometers per second, ladies and gentlemen, not per hour. We are traveling at phenomenal speeds. Azerspace-2 Intelsat 38 was built by Space Systems Loral, the US manufacturer based in California.
Acquisition de la télémesure par la station de Malindi au Kenya. Il reste moins de 2 minutes de propulsion de l'ESC.
"24 minutes and 10 seconds into our flight, we had confirmation back there that we've picked up the signal now at the tracking station in Malindi, that's in Kenya. So we're crossing Africa and about to start heading out across the Indian Ocean. So how does Ariane know what to do and when? Well, the upper stage has a brain.
Il reste moins de 1 minute de propulsion de l'ESC.
He's telling us that we've got 1 more minute left on propulsion of the upper stage. And the brain is the intelligent part. It's called the Vehicle Equipment Bay. It's actually more than an onboard computer. It's a whole management system. And it analyzes information from the engines, the navigation, etc. And it actually makes decisions for the best outcome of the mission. So right now it's getting ready to switch off the engine. It'll send the cut-off command when it senses that the launcher is correctly orientated. So the launcher has to be on track, it needs to be going in the right direction. It needs to be on time, and the computer knows that it must fly from 0 seconds to 25 minutes and 25 seconds, and it has to be going at the right speed for us. That's 9.34, and the right altitude, that's 662 kilometers. And all those parameters
Extinction de l'étage supérieur cryotechnique sur commande de guidage.
Are met, so we are now able to switch the engine off because the vehicle equipment bay, the onboard computer, has sent the signal. So we're entering the next phase now of the flight.
Début des manœuvres de basculement au profit de Horizon 3E.
So he's telling us that we are starting the maneuvers, the orientation maneuvers now. We're in what we call the ballistic phase. Ballistic means without propulsion. So we're traveling high enough and fast enough to cruise without the engine. I guess you could say that we're on celestial autopilot right now. So for anyone who's unfamiliar with a launch, Ariane delivers the satellites onto what we call a transfer orbit. For Horizon 3E, the first satellite to be released, that is just over 1,000 kilometers altitude. It's actually 1,108 kilometers above the Earth, to be precise. And it then has to travel to its final position in geostationary. Now, we are looking here at the teams in the CVI, the Real-Time Visual Control Center, and these guys and girls are receiving the information that comes in from the tracking stations that we've been looking at. And they make a quick selection of the information coming from Ariane to check how the flight is progressing in real time. And then they tell the range operations manager when they've confirmation of the main events, so that the range operations manager can then announce them to everybody else across the range. So he said début de la mise en spin, so the beginning of the spin maneuver. Some people like to call this process the space ballet. Basically, once we release the satellite, as I said, it has to travel to its final orbital slot 36,000 kilometers above the Earth. And so for it to be able to do that, we have to put it into a very precise attitude for its journey. Right now, we are orientating the upper stage so that it can release the satellite onto its correct orbit. Our injection altitude for Horizons 3E, as I said, is 1,108, and this is the scheduled moment of separation.
Séparation horizon 3E.
And we have confirmation there of separation of Horizons 3E. You can see it on the right-hand side, moving away from the mothership. So congratulations to all the teams there. We do have separation, but of course we need to hear from the satellite, who needs to call home and tell us that it all is going well, and that's something we'll get. That acquisition is something we'll get later. So we still have Azerspace-2 Intelsat 38 attached, and that's got an even longer journey because we need to climb to 4,340 kilometers above our planet before we can release it. So it needs to go for another 3,000 kilometers or so. It's going to take about 14 minutes to get there. And there'll be a number of maneuvers as well when we get there in order to start the process of separating the satellite. You can really see the sort of trajectory we've taken. We've crossed the Earth there and flying higher and higher into space. For Horizons 3E, work is really just beginning for the Intelsat teams. And they'll certainly be concentrating very hard, I guess, right now, as they monitor their satellite's first maneuvers. They'll be watching over the satellite's activities in the coming months. Let's go over now to Todd Schilb from Intelsat to find out a little bit more about what's going to be happening.
Good evening, I'm Todd Schilb, the Intelsat Launch Vehicle Program Manager for Horizons 3E. I'm pleased to be back in Kourou for another launch campaign, and I'm especially excited to take part in the 100th launch of an Ariane 5, an epic milestone for the Ariane 5 launch vehicle. It's also an epic event for Intelsat and JSAT, since Horizons 3E is the 5th epic satellite delivered by Boeing Space System. Thank you to everyone involved in this endeavor, and a special thanks to our dear friend and colleague, Christophe Bardou. He's been our partner in launching Intelsat satellites for over 30 years. Thanks again, Christophe. Go Horizons 3E. After separation from the launch vehicle, 7 apogee motor burns are planned, with the last one ending on the 6th of October. After that, solar panel and xenon thruster deployments will follow, and bus testing is planned to complete on the 13th of October. Payload testing will be next and will continue through the end of December, with the goal of entering Horizons 3E into service by mid-January 2019.
Bottom left-hand side of our screen, you can see there our altitude. We are really climbing now. climbing into space. He was telling us that the maneuvers for the cylinder are all going according to plan. You can see it there. It's that black structure at the front. So if you're unfamiliar with what we're looking at, to the left-hand side, the disk, if you like, the grey and white disk, that's what's left of the Ariane 5 launcher. It's called the upper stage, and the cylinder is a very clever structure because it helps us and enables us to have dual launches on Ariane 5. And if you just look to the right-hand side of the screen at the cylinder, the black structure, you can actually see where it's in two parts, rather like a fairing. You can see that sort of whitish zigzag line. The cylinder is specially designed to, as I said, enable dual launches, and it provides the attachment mechanism at the very front for the upper satellite. And in the same way that a fairing protects the satellite underneath, this is what the cylinder is doing. But of course it's not protecting us from friction, because we don't have any friction up here now in space. So we've travelled 12,500 kilometres across our planet. Quite a distance. Excuse me, all in 33 minutes and 29 seconds. There you go, that's a good shot there of our flight path. And our white dot is our rocket, or what's left of it. We're really climbing now in altitude, and you can see that on the right-hand side of our screen. So the next thing that we will be waiting for will be the separation of the cylinder, which means Système de lancement double Ariane in French, system for double launches for Ariane. And of course, the Ariane launch vehicle has, as we heard, undergone a lot of changes over the years. And Ariane 5, with its various versions, capable of taking all kinds of customers to all kinds of different orbits. And Ariane today, the 100th Ariane of the ECA version, which has been the most used version of the Ariane 5 launch vehicle.
La manœuvre d'orientation au profil du Sildas se déroule nominalement.
And he's repeating again that the maneuver is all going according to plan. We're looking here at some images from the drone. This is actually the Jupiter Control Center, and that might look like the real Ariane on the pad there, but it's not. It was a model of Ariane 5, and it's actually not quite a full life-size model. It's probably about a three-quarter size model. Very lifelike. So we're looking here at the upper stage, the disk that's containing the vehicle equipment bay, which is guiding us. This is the scheduled moment now for separation of the cylinder. There it goes. You can see how it moves away in a very carefully planned set of maneuvers. It's called collision avoidance. It's all part of the plan.
Séparation du système de lancement double Ariane.
And now we have the confirmation there of separation of the cylinder. So we can see our satellite underneath for the first time, Azercosmos 2.
Début de la manœuvre d'orientation au profit d'Azerspace-2.
Azerspace-2, I meant to say. Intelsat 38, and he's telling us now we have the beginning of the next set of maneuvers as we start the process now, getting close closer now to separation of our second satellite. But we do have a little way to go. We've still got to climb above 4,000 kilometers above the Earth. And you can see again there the image from the drone and the curvature of the Earth. Amazing to think that it's so thin. But let's go over now to another film.
Azerbaijan. We are Azercosmos, premier satellite services operator in the South Caucasus. As of February 2013, we have played a role as an important gateway in a joint space that connects more than 50 countries in Europe, Africa, Central Asia, and the Middle East. In 2014, we took over the rights to operate and commercialize Azersky, high-resolution optical Earth observation satellite, and entered into the commercial business of Earth observation services. Now we are launching Azerspace-2 telecommunication satellite that will enhance our coverage area and spectrum of services. Built for Azercosmos by SSL, Azerspace-2 is telecommunication satellite with 35 active transponder Ku-band payload. Its designed lifetime is more than 15 years. Azerspace-2 will serve Europe, Central and South Asia, the Middle East, and Sub-Saharan Africa with high-power Ku-band from 45 degrees east. The new spacecraft is ideally designed for smaller antenna and has cross-connectivity between East Africa, West Africa and Central Africa, Europe and Central Asia. We are agile, and our activity is based on values such as integrity, customer satisfaction, professionalism, team spirit, and sustainable growth. At Azercosmos, we are connecting people. For this, we utilize all the advantages of fast technological development. Technological development is based on human factors and designed for people. Azerbaijan recognizes that development of human capital is important for a better future for humanity. That is why we are bidding to host World Expo 2025 in Baku under the title Developing Human Capital, Making a Better Future. Technical excellence complemented by customized approach.
Lots of exciting things happening there at Azercosmos for Azerbaijan. And this is the second time, of course, that Arianespace has been supporting the development of Azercosmos.
Poursuite nominale de la manœuvre d'orientation au profit de Azerspace de Intelsat 38.
And we launched the first satellite for them, Azerspace-1. Azerspace-2 getting ready to increase the coverage area and spectrum of services provided by Azercosmos, so a very important satellite there. And also for our friends at Intelsat, Intelsat 38. So we're in the process of orientating the satellite. Just a reminder of the altitude we need to get to, 4,340 kilometers. That is our injection altitude. And our speed will be just over 8 kilometers per second, I believe. And you can see there our distance from the pad. We have travelled 14,500, nearly 15,000 miles. It's amazing to think that that thin blue line that we're looking at there, the atmosphere of our planet, is so thin, as I was saying earlier, in the sense that it's such a small line. It's our gas mask, the gas mask that is allowing Earth to thrive here on Earth. Sorry, allowing life, rather, to thrive here on Earth. And this is the scheduled moment now for separation.
Azerspace-2, Intelsat 38.
Well, congratulations there to all the teams. We have separation of our second satellite, Azerspace-2, Intelsat 38. Congratulations to all the teams at Intelsat for both satellites and to the teams at Azercosmos. Obviously, we will be wanting to hear from those satellites to check that all is going well up there in space, but there's lots of smiling faces. We started off, we had a red status panel earlier in the launch, we had a delay, but it all sorted out in the end. And we're waiting now for the speeches. And before we do that, let's just